Hello everyone, hopefully you're doing well. In this video, we're going to complete chapter 2, equations, inequalities, and problem solving. If in this one, we're going to take a look on 2.7, absolute value inequalities. If for some reasons you miss any of the previous sections, I strongly advise you to log in and connect and watch videos where I covered linear equations in one variable, an introduction to problem solving, formulas and problem solving, linear inequalities and problem solving, compound inequalities, and absolute value equations. As I stated before, in this video, we're going to take a look on absolute value inequalities. Objectives we pursue in this video lecture is we're going to learn how to solve absolute value inequalities of the form absolute value of x less than a, because we're going to have two forms of them. We're going to have absolute value of x less than a, and we're going to have absolute value of x greater than a. All right. Let's start with the absolute value of x because we can start from here where you see absolute value of x less than a. Remember, absolute value. Absolute value, we expect that the answer should be always positive, but because it's a combination between absolute value and equalities, we can assess equal like this one. So at this point, we know that x for this one, we're going to have two equations. The first equation is where x would be greater than negative a, because x should be always greater than a negative number, and b, where x would be less than a. Now, we're going to solve these two inequalities. In the second objective, where we're going to solve values in the form absolute value of a greater than a, it's going also to give us two inequalities. So over there also, we're planning on having two inequalities. The first inequalities we're going to have is where x would be less than negative a, and b, x would be greater than a, right? So we're gonna have these two. We can come back at any times if you feel uncomfortable. If you forget, also come back to the slides and then see what are the properties. So let's do it right there. We said if a is a positive number, well, the first thing we said, if a is a positive number, then absolute value of x less than a is equivalent to x would be between negative a and a. Like I said, if you have x, absolute value of x less than a, then it gives you two inequalities. The first one, x would be greater than negative a. That's what we have. Sorry, I'm gonna just do that part. No, drawing. So that's what we have here. Okay. And then 2x is really less than 8. That's what we have down here, right? So we have two inequalities. Let's see this very quick in examples where we said, you know what? X is between these two numbers. So we can either do it like solving a x plus 4 should be between negative 6 and 6. So that should be fine. You know, if you want to solve it this way, if you want to solve it this way, it's all fine. But if you don't want to solve it this way, you can also always set two inequalities and solve. So we can subtract 4 from everywhere. If you subtract 4 from everywhere, it's going to give you x would be between negative 10 and 2. This is the solutions. This is the solution. And because the inequality symbol is strictly less than or greater than, we know solutions would be -10 and 2. Remember, when you solve inequalities, pay attention to the symbols we use, because here I put parentheses. Parentheses means, strictly less than or strictly greater than. It's not a set of solutions like for x's when we just solve an absolute value equations with only x's. All right. So this one, we make sure that we use parentheses because it says strictly less than or greater than. The same way on a number line, if they ask you to show your answer on a number line, if we set -2 here, 1, 2, 3, that +2, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, -10 here. That means the solutions would be this line. Okay? So that's a graphical solutions for this inequality. Now, we also can have this one. Remember, when you solve, you make sure the absolute value term is on one side by itself. So I need to isolate it by subtracting 6 from both sides. So I end up with x, absolute value of x minus 3 is less or equal to 1. Okay, remember, either we say strictly less than or equal to, these properties are the same. I only use less than, but suppose you use less than or equal to, you can just say it's like this, like this, like this, like this, like this, okay? It doesn't matter whether it's strictly less than or strictly greater than, we can still use the same. All right, now we know for x would be between, x minus 3 would be between -1 and 1. If we add 3 to everywhere, we end up with x in the middle between 2 and 4. That's the solutions for these examples, 2 and 4. 2 and 4, remember, in terms of interval notation, you can just interval notation. You can say it's between 2 and 4. You see, I close it. But if you do graph, it would be, suppose this line is very straight. We take 0, 1, 2, 3, and 4. Okay, so we know it would be between 0, 2. Remember, you can either use bracket or use a big dot, and this is the answer. Okay, so that's a good, beautiful answers that we can have on both sides for these equations. Now, let's see another one where they ask you to solve absolute value of 8x minus 3 less than -2. See, you cannot have absolute value less than a negative number. Well, that would never happen. An absolute value cannot be less than a negative number. Since it cannot be negative, so we don't need to try anything. We just said no solutions. Okay, so if they ask you why, you just said an absolute value cannot be less than a negative number. Cannot or can't be less than a negative number, right? Since it can be negative, right? Since it can be negative. No, it cannot be negative, right? It cannot be negative. If you try another one, we're gonna try another one. Let's try this one. I like this one a lot. So we see that we solve for x in this one. That's an absolute value that's less than or equal to. The absolute value of any expression will never be less than or equal to 0. All right. it cannot be less than or equal to 0. So I don't need to do two sides. So you remember, I don't need to do two sides. I don't need to do 1 is 2x plus 1 over 3 less than 0. So because that doesn't make any sense. So I can just go ahead and says it's equal to 0 because it cannot be less than 0. It can be equal to 0. All right. So it can be equal to 0. So the sign, the absolute value of any expressions will never be less than 0, but it may be equal to 0, all right? Because it may be equal to 0, what we're gonna do, we distribute the 2x. Let's distribute the 2x plus 2 over 3 equal to 0. Now, if we get rid of the 3, so what the best way to get rid of the 3 is to multiply both sides by 3. Okay. Now we can cancel these two. We still have 2x plus 2 equal 0 times 3 is 0. If we subtract 2 from both sides, we have negative 2 on this side. We have 2x equal negative 2. Get rid of the 2. That is the coefficient of x by dividing by 2 both sides. So x is negative 1. Okay? So we can say that the solution set is only negative 1. Okay? This is the solution set, right? Because we cannot say it's less than 0. Now, so far, the one we do is, when absolute value of x is less than a, we said we have two solutions. It's either x less greater than negative a, or x is we said x. In this case, we said that either x is greater than negative x or x is less than a. That's what we did. Now, the second objective we pursue in this one, remember that, is when a is positive, then absolute value of x greater than a, you said if absolute value of x greater than a, then you have two solutions. Either you have x less than negative a or x greater than a. Remember, if you want, you can still put the less than or equal to symbols to it. So it doesn't matter. Okay, it doesn't matter if that's the case. Now let's do a few examples to complete this chapter. Remember, you cannot have another number on the same side with the absolute value expression, so we need to isolate that term. And now we're gonna have strictly absolute value of 10 plus 3x is greater than 1. Okay, we have greater than. Because we said greater than, then we know we're gonna have two equations. 10 plus 3x must be less than negative 1. And the second equations would be 10 plus 3x greater than 1. Okay, I mean less than negative 1 and then greater than 1. So if you subtract 10 from both sides, 3x less than negative 11, okay? Less than negative 11, and if you divide by 3 from both sides, x is really less than negative 11 over 3. This is the first answer. This is the first answer. The second answer, if we subtract 10 from both sides here, it gives us 3x greater than negative 9. If we divide by 3, from both sides, x is greater than negative 3. Now, there is a very funny ways of expressing the answer in this case, so it's either or. Remember, in this case, when you have absolute value of x greater than a, when we said the solutions is either x is less than negative a, or x greater than a. When we do that, or means union of set. So meaning we need to take everything. So what's the solution? Solutions would be, remember this one we can take in terms of interval is negative infinity, negative 11 over 3. We use parentheses. And this one is greater than negative 3 is 3 to infinity. So in terms of solution set, we can write our solutions as on an interval notation. I mean, we can say is negative infinity, negative 11 over 3, union 3 infinity, because we're dealing with a union set. So it's like we do a compound inequalities containing or it's a compound absolute inequalities. All right, so we can call it this way as well. All right, so I think we have two more to go. Let's do the next one. For this one also, they ask you to solve x plus 2 greater than or equal to 0. Remember, we said equal to 0. We cannot say less, some of them less than 0. So let's say it doesn't matter. You said plus 0, negative 0. So you know 0 is not that. So do we even need to show that x plus 2 would always be equal, greater or equal to 0? That's true. That's true for all equations. The solution is all real numbers since all absolute values are non-negative. We already know it's going to be non-negative. Why we need to show this again, okay? So we don't need to show that. So the solution is all real numbers. Solutions, all real numbers. Or we usually say solutions. When we say all real numbers, we say like this. Solutions is all real numbers. Or you can write it solutions is negative infinity, infinity, right? So either one. So any values for x we substitute into this inequality will give it as a true solution. So either you include a negative number or a positive number, all of them would be greater than 0. Equal or greater to 0. So negative 2 would give you definitely 0, but after that, any number you enter there would be greater than 0. So that's why we don't need to do that, because all absolute values are non-negative. All right. Last one to complete this chapter. We see here we can still have two of them also. The first equations, we're gonna have 7 plus x over 2. We know that will be less or equal to negative 4. And for b on this side, we're gonna have 7 plus x over 2 would be greater or equal to 4. So two equal inequalities to solve. On the left, if we definitely need to get rid of the denominator by multiplying both sides by 2. You remember, if you cancel 2, we're gonna have 7 plus x less than or equal to negative 8. If you add 7 to both sides, x would be less than or equal to negative 1. So solutions interval here would be less than negative 1. That means you have negative infinity, negative 1, but with a bracket. Bracket would tells you that, oh my God, so we subtract, that's my fault. We subtract. So when we subtract 7 from both sides, this one gives negative 15. So answer would be negative 15. That's one side. The other side also, in order to get rid of the 2, we multiply both sides by 2. So we end up having, we cancel these 2. So we have 7 plus x greater or equal to 8. If we subtract 7 from both sides, that's what I did before, I think. So x would be greater or equal to 1. So in 1 infinity, but not parentheses, that should be a bracket, because it's greater. We start from 1 to infinity. The first one, we start from negative infinity. after negative infinity to up to negative 15. So solution set would be a union of set. That means it's negative infinity, negative 15 with a bracket, union, bracket 1, infinity. I definitely believe all of this exercise will help you to complete every homework you may have. All right, look at this one on a number line. I'm gonna put a number line here for you to see. Okay, if I put 0 here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I have 1 here, 2. Okay, this is what we said in terms of formulas, right? We said this is the solutions on the left, and this is the solutions on the right. We use bracket, right? If it was something about and, you would say no solutions because there's no common area here. So you can see both of them goes different directions. If they're asking you to graph, that's what you are going to do. I hope all of this really help you to understand equations, inequalities, and absolute value. You can solve any formulas for a variables. If you have any questions, do not hesitate to contact me. Do not hesitate to contact me and I'll answer any of your questions. Take care and have fun.